Welcome back all the fans and followers of space fiction. The last time I got lost at the bottom of the Vallis Marineris on Mars, I realized how important space infrastructure is. Infrastructure is a very broad concept. In general, it is a group of devices or objects that allow people, resources or informations to be transported from one place to another. Today, therefore, we will take a closer look at space navigation, which is the second very important part of space infrastructure. Wherever you travel on Earth, you can navigate anywhere under the sky using GPS, GLONASS, Beidou or Galileo satellite navigation. The network of these satellites covers the entire Earth. But how do I know where I am when I'm not on the Earth? If I climb higher and higher above the Earth's surface, the signal from the navigation satellites will still be available. Even at the height of the ISS, it is possible to receive this signal and measure your position and velocity relative to Earth. Navigation satellites orbit the Earth at an altitude of 19 to 23,000 kilometers above the Earth's surface. Above this distance, however, the signal may be very weak, if not completely unavailable. The antennas transmitting the navigation signal are oriented towards the Earth and not into the surrounding universe. Interplanetary probes control their orientation in space using the position of stars, the Sun and planets. The Sun and the stars are stable points for them, and we can also determine the position of the planets in space very precisely. So trying to invent a navigation system for interplanetary flights would be useless. It would not be unrealistic, but navigation using satellite signals in interplanetary space has many disadvantages. The signal does not have such a large range that a reasonable number of satellites can cover the entire path of the spaceship to Mars. In addition, at each point, the spaceship would need to receive a clear signal from at least 4 navigation satellites at once. And all navigation satellites need to be in contact with a common reference point with some control station. And in a space like our solar system, this is not realistic at all. So we will still use navigation dependent on the stars, the Sun and the planets for a long time during interplanetary flights. What we lack, however, is navigation on the surface of alien planets. Theoretically, even on space bodies without an atmosphere such as the Moon, the orientation towards the stars, Sun and the Earth could be used, but such navigation would be very inaccurate. In addition, it could not be used when moving on a surface with a vehicle. Imagine trying to aim your telescope at a star while traveling in a car. That is simply not possible. So for the Moon as well as for Mars, we will need a system of satellites that transmit navigation signals just as we do on Earth. Despite the fact that both bodies have a weaker gravity and a smaller diameter than the Earth, approximately the same number of satellites will be needed here as well. They may be in a lower orbit or move more slowly, but their number cannot be less to cover the entire surface of the planet. Therefore, it will be ideal when you start launching satellites of the Moon and Mars from the surface of these bodies. The Earth cannot be the only source of the origin and development of all technologies anymore. Otherwise you will never find the Apollo 11 landing monument. In the next video, we'll look at the most important part of space infrastructure, the space communication. Thank you for watching, and the next time I fly by the Earth, I will send you another video from the world of space fiction.